So these snow measurement activities, they are very important in order to understand the Earth radiation budget. So when we measure here the snow albedo, it tells how much of the radiation coming from the sun reflects from the Earth's surface back to space. It's very important to know how this snow cover affects and what kind of influences it will have. And in order to find out that, we need these kind of activities which are going on now within this Snortex campaign.
So we have many teams being on the ground and to measure snow properties, particular grain size, snow depth, snow edging, and we have also some airborne measurements from helicopter. The airborne measurements, they include some instruments that are also flying on satellites, so they are like a prototype. So we have instruments that measure the reflectance, which came back from the boreal system. In particular, we look at the spectral properties from visible to near-infrared. We have some fisheye cameras, and we also some instrument called Osiris, which is flying on the satellite too, which allows to look at the surface of the different angles and also different spectral bands. Because of Osiris, in particular, we are able to reconstruct the architecture of the canopy, including the boreal layer, the forest layer, and also the snow layer. So Osiris instrument is a prototype of polder which is flying on the spaceborne actually parasol. So you can see there is two optical lens, one in the visible, the other one in the middle infrared. So the design concept of the instrument is to quite look at the surface at different angles. There is what we call the CCD matrix, and we have a concept, which original concept is to have a wheel with a filter going around. So each sequence you can look at the surface with different spectral bands, and also yes, the polarization of the surface, which is important for snow, for instance. This is an important contribution.
The Snortex campaign will provide both airborne and ground-based data for developing algorithms of snow albedo and various snow products using satellites. The airborne instrumentation we are using are measuring the reflectance of the land cover, both the directional dependence and then the total reflectance from all directions. We also measure the incoming radiation from the sun in all wavelengths and all directions when it is diffuse condition. Then we measure the ultraviolet radiation, both incoming and reflected one. In addition, we have a wide optics camera used for the leaf area index retrieval of the canopy. Then we have ground-based measurements. We measure the depth, density and snow water equivalent of the snowpack to get sort of coarse resolution information or very basic information of the snow properties. But since the albedo is very much related to the surface structure and surface properties, we have dedicated measurements also to characterize the surface in more detail. The Finnish Geodetic Institute is making surface roughness measurements using a laser scanner, and then they measure the directional dependence of the reflected radiation using the Figo spectrogoniometer. In addition, the Finnish Meteorological Institute makes surface roughness measurements in various scales, 1 meter, 100 meter, and even some 10 centimeters. And we measure the grain size of the surface and then the impurity content of the surface. But some instruments used in satellites to derive snow properties are operating in microwaves, and they can see the properties of the snowpack deeper down, not just the surface but the whole snowpack. And for that purpose we measure also the temperature profile and the grain size profile and the density profile and the moisture content profile of the snowpack. And these measurements are carried out in an area of about 10 kilometers times 10 kilometers, where we are then doing these airborne measurements, and we can compare the airborne and ground measurement information with each other.
This campaign, especially Snortex, is one very good example of these lasting 3 winters, and also a good example of the international cooperation, because none of the campaigns is our own, and we always have visitors here using our facility, using our technical staff and all the support from our side, but they also come here to make own measurements during the campaigns.
So all of these things within the Snortex campaign can be repeated with different campaigns, and has been done last years and will be done in the future.
One problem in currently used climate models is that the description of wintertime forest is problematic. If the vegetation is not taken into account, the albedo is too high, and if the vegetation is taken into account the same way as in summer condition, then the result is an underestimation. The reason is that the interaction between the canopy and the highly reflective snow at the forest floor is not included in current models. And one objective of the Snortex campaign is to develop a proper description for the reflection properties of boreal forest, which is very important for the climate and climate change. One of the main problems for the climate change issue today is what happens to the boreal forest zone.